All right, this last section in chapter R is all about properties of real numbers. Now, this is a lot of sort of language and knowing how it's used. And when I first started learning this, I thought it was kind of garbage. I was like, why would you ever call these things? But I've noticed now that as I teach longer and longer, I start using these properties more and more. It's all about how you know when you're allowed to do what. Because sometimes you're allowed to move things, sometimes you aren't, sometimes you're allowed to put brackets in, sometimes you aren't. And being really concrete in these properties is going to help you know when you're allowed to do what. So the first thing is one that most people know, which is called just the distributive property. All it is that when you do order of operations always says that you have to do the bracket first. So here I would do 3 plus 5 is 8, so that I get 2 times 8 is 16. The distributive property says that you're actually allowed to do multiplication first, as long as you distribute the multiplication through the bracket. So if I have 2 times 3 plus 5, I can multiply the 2 through as long as I multiply it by every term in the bracket. So I would have 2 times 3 plus 2 times 5. And then 2 times 3 is 6, 2 times 5 is 10, 6 plus 10 is 16. So the distributive property is kind of a workaround for order of operations to allow you to distribute a multiplication through. So all it is simply that we are going to distribute. So this would be 3 times x plus 3 times y. And that's as far as I could go with that. In this one, you're multiplying a negative 2 through. So maybe this one you choose to actually show it. So it'd be negative 2 times 5 minus 2 times negative k. That would give you negative 2 times positive 5 is negative 10. Negative 2 times negative k would be positive 2k. And then lastly, if you have 3 terms in your bracket, just make sure that you distribute through all 3 terms. So 6x plus 12y minus 18z, and that's it. Objective number 2 is your next property, which is your identity property. And an identity property is what can you do to a number to not change its identity? So there's what can you add to a number and not change its identity, and what can you multiply by a number and not change its identity. So the answer to what can you add is that you can add 0. If you have a plus 0, it's still a. And people are like, well, why would I ever use this? Well, in chapter 8, we are going to be doing a thing where you are going to be creating perfect squares. So you're going to want to add a number to an expression. Well, you're not allowed to just add a number because you're going to change its value. But if you add the number and subtract the number, you could potentially use this part together and it would have the same value as just x. So in other words, x plus 3 and minus 3 is still equal to x. I didn't change its identity because I added 0 to it. Okay, the next one is what can you multiply by a number? Now this one we've already used. If I have a fraction like 2/3 and I want to create a common denominator of 6, I can multiply by 2 over 2. Why? Because I'm multiplying by 1. When you multiply something by 1, you don't change the identity. So even though this 1 is 2 divided by 2, it's still 1. And so I haven't changed the ratio of 2 to 3. Okay, now this property is often seen when you have a lone variable like x as well. Everything that's just a variable by itself is still 1x. So multiplying by 1 doesn't change its identity, and so we leave the 1 off. So for example, if you ever see a y plus a y, this is 1y plus another 1y, which would give us 2 y's if we were collecting like terms. Same thing here. If I have negative out front of a bracket and I'm thinking, oh, this looks like the distributive property, but I don't know what I'm distributing, this is actually negative 1 times 5p minus 3q. So I can distribute the negative 1 times the 5p and the negative 1 times the negative 3q, and I could get negative 5p plus 3q. So just knowing that hidden ones are there all the time, we often don't write them because they don't change the identity of a variable. Okay, this multiplicative identity is used a lot to write with fractions, so I already talked about this. If I wanted to change 2/3 to have a denominator of 6, I shouldn't have written that above. I always get ahead of myself. I create these notes, and so sometimes I forget that I'm going to talk about that thing later. All right, The next properties, we've had the distributive property and the identity property. The third property is the inverse property. There's the additive inverse, which if you didn't see that you didn't have to do one of the objectives, I think in R.1 maybe, you might have already talked about additive inverse, but additive inverses always have a sum of 0. So for example, if I have a 5, the additive inverse is -5 because that will give me 0. If I have -1/2, the additive inverse is +1/2 because that would give me 0. If I have -34, the additive inverse is +34 because that would give me 0. And again, the question is, well, who cares? Why would I ever do this? Think of solving algebraic equations. If I have x plus 3 is equal to 5 and I want to get x by itself, I have to get rid of 3. I'm going to use the additive inverse of +3, which is -3, to get rid of it. Now, the added part is that if you're solving an algebraic equation, what you do to one side, you do to the other, okay? But the key thing is that this additive inverse is really important. Additive inverses always add to give you 0. Then we have the multiplicative inverse. So just like the identity, where you add 0 to not change the identity, with multiplication, you multiply by 1 to not change the identity. Well, here what we're trying to do is get 1. So up here we tried to get 0, here we're trying to get 1. So in other words, what is the multiplicative inverse of the following? So what can I multiply 5 by to make 1? Well, I can divide by 5. Dividing by 5 is actually the same as multiplying by a fifth. So the multiplicative inverse of 5 is a fifth, because 5 divided by 5 is 1. The multiplicative inverse of dividing by -2 would be multiplying by -2, right? -2 divided by -2 is 1. The multiplicative inverse of -34 would be dividing by -34, or multiplying by 1 over -34, because that would give you 1. So the last two properties, I know this is a lot, I'll summarize it at the end, are the commutative and the associative properties. And what that is that you are allowed to change orders or put brackets into expressions and not change their value. So before we get there, a little bit more terminology. What is a term? A term in an algebraic expression is a number or the product of a number and one or more variables raised to a whole number exponent. So for example, 2x squared is a term. -4 is a term. 3xyz is a term. If I look at this expression here, I have one term. So this is one term. Here, I actually have 3 terms. The first term being 3x squared, the second term being -9x, and the third term being +12. Here, take a second, see if you can guess, maybe pause the video. There are 2 terms, the first term being 3a cubed, and the second term being -12ab squared. You'll notice I always take the sign in front of it as part of the term, because now what we're going to be doing is potentially moving them, and you have to make sure you take the sign with it. The coefficient, another sort of terminology, is the number that's in front of the variables. So the coefficient in this case is an 8, coefficient in this case is a -5, and the coefficient on y is 1. We're going through this because we're going to have to do a lot of combining like terms, so just bear with me, we're not actually into the property yet. So like terms are any terms that have contained exactly the same variables raised to the same powers. So 6a, 7a, like terms. If I have 6a's and 7a's, I can say that I have 13a's. If I have -5m cubed n to the 4's and 2m cubed n to the 4's, I can say that I have -3m cubed n to the 4's. Whereas if I have 6a squareds and a 7a, they're not like, so I can't combine them. Same thing if I have m to the 4 n cubed and m cubed n to the 4, they're not like, I can't combine them. Okay, so combining like terms, you're allowed to combine like terms as long as they have the same variable with the same exponent on it. All right, so to be able to combine like terms, we need 2 properties. So here we go. Property number, I think we're on 4, right? We had the distributive property, the identity property, I shouldn't have tried to recall, identity property and the inverse properties. Last 2 properties are commutative and associative. The commutative property is that the order of numbers being added or multiplied don't matter. For example, 3 plus 9 is 12. Well, 9 plus 3 is still 12. 3 times 9 is 27. 9 times 3 is still 27. So why would we care about this? Well, if I have a list of terms like negative 2m plus 5m plus 3 minus 6m plus 8, I'm allowed to group like terms together because I can move terms around due to the commutative property. It doesn't matter the order of the addition as long as I take the sign with it. So in other words, I'm going to take this plus 3 and I'm going to move it over here. I'm going to commute it so that I can combine like terms. Now I have negative 2m's plus 5m's, take away 6m's, which would leave me with negative, and here I'm commuting again, negative 2m minus 6m is negative 8m, plus 5 would give me negative 3m, and then 3 plus 8 is 11. Okay, and then the same goes for multiplication, right? You're allowed to just move them around. And then the associative property is a little bit different. It's about who you associate with. If you could see me right now, I'm like, got my arms around two people beside me. I'm associating with them. So my arms are like brackets. You can change where brackets go with addition subtraction. Because order doesn't matter, it doesn't matter if you add the two end numbers before you add the first number or vice versa. So if I have 5 plus 7 in brackets plus 2, that would give me 5 plus 7 is 12, and 12 plus 2 is 14. If I changed where the brackets were and put them around the 7 and the 2, this would be 5 plus 9, which still gives me 14. Same is true for multiplication. 5 times 7 is 35, times 2 is 70, or if I did 7 times 2 is 14, 14 times 5 is 70. It's funny that the textbook teaches R.4 after R.3, because I feel like a lot of this is useful for order of operations, but it is kind of done specifically here. But you could have used this for some of the questions that you had done previously. So just as a summary, there are 4 properties that I've listed here, plus one more. There's distributive. I never put it in here because the distributive property doesn't have distributive. The distributive property doesn't have an addition and a multiplication property. It's just distributive. So there's 1 and then 2, 3, 4, 5 properties that you're responsible for. So the key thing is that the identity property is that you don't want to change the identity. What can you do with addition? You can add 0. What can you do with multiplication? You can multiply by 1. Inverse is that what can you add to make 0? So you're looking at the opposite operation. And then for multiplication, it's what can you multiply to make 1. Commutative is that you can change the order of the terms as long as they're adding and subtracting. It won't change the expression, or if they're multiplying. Now, if you have a combination of multiplying and adding, that's a totally different story. So if everything's multiplying or everything's adding, you can change the order. And then the associative is that you can change who you associate with first. So this is the idea of the brackets. So your textbook has a question very similar to this one, which says complete each statement so that the indicated property is illustrative. So to show the associative property, you would do something like, hey, this says 4 plus 12 plus 8 first. I would change where the brackets are. So I would do 4 plus 12 plus 8. Now to really show that this property is illustrated, I would then simplify. So this would be 4 plus 20. And so I'll draw a line. We're showing that left side equals right side, which gives me 24. And here I get 4 plus 12 is 16. 16 plus 8 is still 24. The inverse property is shown here. You can see that they're multiplying by their inverse, so that should make 1. And then the identity property is that if you add 0, you don't change your identity. You're equal to negative 12x. They're kind of weird questions. The question on the quiz is multiple choice, and it just says what property is shown here. So just be a little bit familiar with them and you'll be okay. It's more to get you ready for the fact that I'm going to be using these properties from now on in the course. So now that you've seen them once, you might know what I'm talking about when I say them again. All right, good luck on chapter R.